Hi everyone, my name is Purity Nyagweth and I would like to present you my project for the KaggleX mentorship. The project I worked on is a bird species classifier. So just a bit of my background before I go into the project details. My educational background is on medical laboratory science, but I transitioned to data science and machine learning, and below are the links to my social accounts. Below is an image of two birds, and perhaps you're wondering what kind of bird it is and would want to know more about the bird, for example, its habitat. Well, imagine a scenario whereby if you have an image of a bird, you can get access to its species and get some basic information about the bird without having to browse through the internet or read through books and articles to get this information. So the aim of this project is to build a machine learning model that takes in an image of a bird and gives out the species and details about the bird as an output. So just a quick note, the project involves two machine learning models, a vision transformer model. This model is fine-tuned to classify bird images. It gives the bird species as the output. Another one is the large language model. The output of the vision transformer model is fed into this model as a prompt to give the details about the bird as an output. So just a summary of how the whole process works. So we start with an image of a bird and end up with two outputs, the bird species and details about the bird. Now we'll go through the project step by step. The data used is the birds 525 species image classification dataset from Kaggle. It contains 525 bird species. It has 84,635 training images, 2,625 test and validation images. The link to the dataset is given below. As a first step in image processing, the VIT image processor is loaded. To process an image, the image is passed through the processor's call to give an output of a dictionary of the pixel values. A transform function is created to include the label ID in the output. The model used is the Google VIT-based model from Hugging Face. The model is a transformer encoder model that was pre-trained on ImageNet 21K at a resolution of 224 by 224. It was introduced in the paper, An Image is Worth 16 by 16 Words, Transformers for Image Recognition at Scale by Dosovitsky et al. The weights were then converted from the team repository by Ross Whitman, who already converted the weights from JAX to PyTorch. Hugging Face's trainer is used for the fine-tuning. Below are the processes required for fine-tuning. Defining a collate function. The data collator is used to create batches from the dataset. These batches can be efficiently processed by the model during training. Defining an evaluation metric. During training, the model needs to be evaluated to determine how well the training is going. For this project, the metric used is accuracy, which measures the proportion of correct predictions out of the total number of predictions. Then, loading the pre-trained model. After that, setting up the training configuration. This is done by defining the training arguments, such as the number of epochs, the evaluation steps, learning rate, and so on. Then finally, training and evaluating the model. So these are the training results. So as we can see on the graph on the left, both the training and evaluation loss decreases and then stabilizes at a point. So this graph is an indication that the training went well and that the model is well fitted. This other graph is for the model accuracy. So as we can see, the accuracy increases and also stabilizes at a point. The best model had an accuracy of 96%. The large language model used is the Okra Mini 3B, also from Hugging Face. It is an Open Llama 3B model trained on explain-tuned datasets created using instructions and input from Wizard LM, Alpaca, and Dolly V2 datasets and applying Okra research paper dataset construction approaches. To make the predictions, the model and tokenizer are loaded. Then a prompt is defined. The prompt should include the bird species quoted from the vision transformer model. So the prompt is then fed into the tokenizer, which does the encoding and produces tokens. These tokens are then fed into the large language model, which generates the bird details. The model is deployed with Flask, which is a Python-based microweb framework that is used for building web applications. For this project, the application has been designed in such a way that the user uploads a bird image. The image is fed into the model, which then predicts the species and details about the bird as an output. The output is then posted as shown in the next slide. So here we've got the image with the species and details about the bird. So in this next slide, I will show how the application works. So just to note, all the images used in the presentation were gotten from pixel.com. Okay, so you can check out this Get repo to get access to the codes used in the project. Yeah, that's all from me, and thank you.